Okay, so let's take a look at number 8. So we're given x minus 1 times x minus 3 over x plus 1 times x minus 2. And the question is to say when is this function true? So the first thing is I always like to do is first to look to see if something divides out. So obviously x minus 1, x plus 1, you don't divide out. X minus 3 doesn't divide out with either of the denominators as well. If it did divide out, you would have a whole. But because you don't have that, then we know that the denominators represent what we call the vertical asymptote. So when the denominator is equal to 0, it's undefined, and what we say occurs there is that it makes a vertical asymptote. So at x plus 1 equal to 0 and x minus 2 equals 0, we have a vertical asymptote, which means at x equals negative 1 and x equals 2, you have a vertical asymptote. Now, I know you can't do this on the exam, but it's beneficial to look at a graph, or maybe you can. So if I look at the graph of what's going on here, if I type in x equals negative 1 and x equals 2, let me change this color, you'll see that the black and the orange colors both have vertical asymptotes at negative 1 and 2. That is what we are illustrating when we write that. Now when the numerator is equal to 0, that would be when x minus 1 is 0 and x minus 3 equals 0, this would mean that when x is 1 and x is 3. These represent the zeros of the function. So what you'll see is at x equals 3 here we have a 0, and then also at x equals 1 you have a 0. Okay? So these are the interesting points here, which are, we can write them out as, we draw a number line here. We said at negative 1, you have a vertical asymptote. At 2, you have a vertical asymptote. And then we know we have zeros at 1, and then also at 3. Okay? So this is the way I like to draw it out, so I know what's a 0 and what's a vertical asymptote. And why do we care about that? Well, if you look at the graph, you care about that because only at a 0 and at a vertical asymptote can you have a situation where the function is going to transition from positive to negative, right? So what you can see in this picture here is that you have a positive, right, up until you get to x equals negative 1, and then afterwards the function is negative, the y values are negative, until you cross the 0, and then the y values become positive after 1, right? And then you have a vertical asymptote at 2, and notice what happens. The function now is negative until what? Until it crosses the x-axis, and now the y value is positive. So what you do, obviously you don't have this picture here, but what you're going to do is you go into the original function, and you just say, hey, I'm going to pick a value less than negative 1. So let's say I pick a value less than negative 1. I'm going to make my font a little darker here. Let's say I pick x equals negative 2. And I plug negative 2 in for all these x values, and I see what happens. Now, when you do this, if you have a calculator, you can just literally just type the function in, right? And I can go under table, and let's say I pick a value less than negative 2. I can just type in like negative 3. A value after negative 1, let's say I pick 0. A value after 1, let's say, but not after 2, so maybe I could say 1.5. A value after 2, but before 3, I put in 2.5, and then a value greater than 3, like 4. And it'll tell me the sign value. So I know go positive, negative, positive, negative, positive. So if you can use a calculator, then you just do that, and it'll say, we know that we're going to basically go positive, negative, negative, and then after 3 it becomes positive. Let me double check to make sure that's true. So positive, y is positive over here, y is negative over here, then it's positive, then negative, and then it ends positive. So it alternates, right? So if you can type the values into, put them in a table, you could just look and pick values. Now be careful. We picked x equals -3, x equals 0, x equals 1.5, x equals 2.5, and x equals 4. So you got to be careful because you do have some ugly numbers here in 1.5 and 2.5. Okay. If you don't have a calculator, you can still do this, right? So if I plug in a value like, what did I say, -2? But I said -3, it doesn't really matter. Let's say -3. So what's going on here? Well, what you're going to realize is you say, okay, well, if I plug in -3 here, -3 minus 1, you don't need the number, you need the sign. You realize it's negative. -3 minus 3, you know that's negative. -3 plus 1 is -2, so you know that's negative. -3 minus 2 is -5, so you know it's negative. So on the top we have negative times negative, which is a positive. Bottom you have negative times negative, which is a positive, and hence it's positive. And you would work through every single one like that, and you would get this result of positive, negative, positive, negative, positive. Okay? If you need more detail on that, please let me know and I'll make another video. Once you do that, then remember the question saying, when is it greater than or equal to 0? When it's greater than or equal to 0, well, values that are greater than 0, that's a fancy way of saying positive. So that would be here, from -infinity to -3. And this is where it gets a little tricky. Because it's an asymptote, it's a parentheses for both, right? Obviously, infinity is always parentheses. This is where it gets interesting. So it's positive next here. That's at 1 to 2. 1 will be a bracket. And the reason why 1 is a bracket is we are saying we are greater than or equal to 0. So we are including 0. This is why in my chart I make a distinction between zeros and asymptotes. It doesn't exist at an asymptote, so it has to be bracket -1 parentheses 2. And then at the end, you see it after 3, it's positive as well. That's going to be bracket 3 to infinity. Infinity always finished with parentheses. So our final answer is -infinity to -3 union 1 to 2 union 3 to infinity. That's a lot. If you are again given a calculator, I would always encourage you first to graph it. I hope that makes sense, and I'll see you in the next math video.